One CPC project, One Chip Personal Computer, Part 8, by Doctor and Engineer Economist Robert-Bela. One CPC proposal, summary for Part 8. One CPC, phases to realize one CPC chip. One CPC, the RSOS, the reduced size operating system. One CPC, accessing RSOS files. One CPC, breaking into the RSOS. One CPC, phases to realize one CPC chip. No money is required at the first phase. This is a call for the people and companies who want to enroll or join and give other resources than money, like know-how and the old architectures or new ones to simplify them. The next phase will begin when every important component of the one CPC chip is enrolled or registered. Please keep your money and put it somewhere aside until the second phase begins. Thank you. I know that trust must be earned. That is why no money is needed at the first step. By realizing the one CPC chip and socket, nobody can lose anything. It is not a threat to anyone. Money collection will begin from the second phase only. One CPC RSOS, Reduced Size Operating System. The iOS operating system has to be open source. It would have a basic internet browser interface with a total commander style interface for file managing. A number of 8 tabs could be used. Every tab is one internet page or one action, accessing or searching files on the PC, listening to music, watching a film, etc. The operating system's loading time is proposed to be under 3 seconds. One CPC has to be a simple to use computer with a few simple commands as compared to the other existing operating systems, Microsoft, Linux, Android, iOS, etc. One CPC could be used also in advanced user mode because a lot of manual functions and commands would exist. Simple to use, but having access to more complicated functions and commands too. You, dear user, are in charge about what and how the programs are running on your computer. The operating system should be written in assembler. I know that it is hard to program in it, but it's very easy for the processor to understand and realize the issued commands. An assembler-like programming language will be needed also for the ARM processor in the future. This is an example of how should look like the user interface of the RSOS. One CPC, accessing RSOS files. The operating system should be like a firmware. The firmware should have 3 layers. The basic layer, loading the operating system. This can be modified, and 2 other changeable or upgradable, manually reprogrammable parts. The operating system UI, it means the user interface, and some extensions for it, for example Flash player or any other software upgrades. Please look to the image above. One CPC, breaking into the RSOS. No hidden files, no hidden programs or routines existing in one CPC system. So if you have a virus, you will see it in action in the program list and in the memory. At a hacker attack, in the worst case, only the L4 will be accessible. The non-volatile memory would be electronically, physically sealed, so nobody will be able to get in or modify its content, only if the attacker knows the exact hex code key to unlock the physical safety circuit. The ROM can be accessed through the USB 0. In medical chips, 24 hex characters will be used, which equals with 96 bits. In the standard end-user chips, 12 hex code will be used, which is equals with 48 bits. One hex character is 4 bit. Only one 48 or 96-bit binary code can unlock the access to the ROM in one CPC chips, each chip would have its own unique binary code and not existing a generic, let's say, master key. 2 on the 48th power means 1024 by 1024 by 1024 by 1024 by 256 by 8 seconds per one try to get into the internal non-volatile memory. This equals with a huge amount of seconds to try all the possible variants in case of the brute force method. This means about 44 million years. This is approximately how much time you need to break in using the brute force method, the worst case scenario. And this is just the case of end user chip, only 12 hex characters. 2 on the 95th power, meaning the 24 hex characters, would be worse to try to get in. Anyway, the implants would be needed to connect to the communication ports too. End of part 8. Thank you for watching.